Hey guys, what's up? Hope everybody's having a good morning. This is the morning space report thing that I'm going to be doing from now on. Just space weather update, just conditions. And if I need to explain some things that I'm seeing, I will. But I'll try to keep it minimal without going off on the side rants. That's why I'm back to doing some of the recorded ones in the morning so I don't do that. The chat distracts me. I like talking to you guys too much. So that's what happens. And I am, again, let me say it one more time. I am sorry that it took me this long to get back to this. I understand people don't have an hour and a half to sit here and listen to me talk sometimes, okay? So I will be doing another live stream today. I may even do two, just depends. If we get anything else going on today in the morning, I will do one. If not, I'll wait till this evening. But if something substantial happens, I will definitely come on and we'll talk about it. So anyway, we got the Schumann here, and it is definitely staying pretty normal, guys. This isn't much to talk about right now. I've addressed this multiple times. I will show it every video because it is, in my opinion, the most important tool that we look at, because this directly shows what we're getting affected by. This is the frequency of the Earth. Well, the 783 is the frequency. And, guys, that's rising. Evidence is here. So, other than that, no spiking going on. If you're having ringing in your ears, guys, this to tell you how important this is, there are heart institutes that use this tool. If this thing's wigging out, they will elect not to do certain surgeries. They're using this to actually help diagnose their patients. So that should tell you how substantial this thing is. And I just got to reiterate that. Space weather. Solar X-ray. We had a little flare there. I think it was like a C1 or something right around the turn of the day, UTC time, midnight. The solar proton flux is kind of, overall falling off here. These flares and stuff will keep this going. So we'll just have to wait and see what's going on with this. Okay? This is radiation. But it is not in storm level. That's what these numbers are. Obviously, the higher you go up, the more it will affect you. Now, astronauts, people that fly in high latitudes and high elevation, should pay attention to this, but that's really who this affects. Basically, the same people that cosmic ray affects. That's usually who's at the most danger here, too, with this radiation from the proton flux. Now, don't get me wrong, if we get way up here into some major radiation storm, we could have issues ourselves, like health issues, that kind of thing. But typically, it takes a whole lot to really get down to us. So, anyway, and it also affects satellites, okay? They can have issues with satellites if the radiation storm is too bad. Geomagnetic activity. We're in the basement, okay? Remember what I said, if we go 12, 16, 24 hours here in the basement with no activity, they will issue a cosmic ray alert. And if we get a cosmic ray alert at the same time we're getting a proton flux alert, seems to me like that would kind of compound. I'm not sure if it really does or not, but having two different things happening at once, again, cosmic rays come in, and this is what blocks it usually. It helps block the cosmic rays. We need some geomagnetic activity. We don't want to be in storm level, but we don't want to be in the basement. Also, we're in the basement right here, guys, and listen. I'm seeing some stuff on the magnetosphere on multiple tools. That our magnetosphere is actually reacting, but this is saying we're not getting any geomagnetic activity. So either our Earth and our magnetic field is really doing a great job, or something wonky is going on here. Okay? Now, as you can see here, first look at the sun. Look, remember what I said about training of the sunspots? In other words, train cars following each other. It's almost like they're evenly spaced. It's kind of crazy. And this is why our X-ray flux is staying high. And this is also why the chances of us catching certain CMEs or flares is elevated too. The more of these we got, the more chance we got of getting that kind of stuff. Here's another one up here. Now, I'm not sure which ones are exactly official sunspots. I know this one is. This one is too, I believe. This one may still be. I'm not sure about this one or this one. I would say they're going to give this one a number because it looked to be pretty intense, but we'll wait and see. Now this is a coronal hole. Actually it's kind of an odd shaped one. It's very, very, you can tell it's completely open, but it's very vertical and thin. It's kind of strange, but we will connect to that if we haven't already done so. And we'll get solar wind from that. There was also another coronal hole that we were connected to yesterday. That's this right here, the remnants of it. Looks like it has closed up just a little bit, but we'll keep an eye on it. ACE data. Everything's all normal up until the blackout day here, right? The blackout time for the satellite, where it loses line of sight and it can't transmit the data. That's what you see there, okay? And some days it's longer than others. That's very normal, okay? But as we're looking at this, the solar wind speed itself is right in the middle. Density is low, actually, okay? 4, proton density of 4 is normal. This is below that. And you can also see, this is what I call popcorn. Look, it's dots and stuff, just up and down, up and down. It means the conditions are very, very variable, okay? That means it's jumping around. High, low, high, low, high, low. If it's staying pretty stable, it looks like this. The dots line up, and it looks like a straight line. But each one of these little dots is a data point. So where you see a dot, it's telling you, like on the yellow one here, that this dot right there, it's telling you it's about 400 kilometers per second. That's how fast it's moving, which is roughly about 1 million miles per hour. But you can see how everything kind of went fluctuant here. But nothing's extreme. That's why it's kind of odd that I'm seeing these hits on the magnetosphere. Now, guys, listen. That's 50. That's 50 on density. That's high, guys. Usually this is reading 0 to 20. So they had to raise the range there because of stereo A. Stereo A is experiencing these conditions right now. We are right here in time. Okay, so it's already had a high dense smack and it's coming down on the end of it. Notice how this looks almost exactly like that because it is the same thing that's hitting us. Stereo A wind speed goes up here. What happens here at Earth? It goes up at the same time. So this is the same source is hitting us with this. Notice over here, the spirographs. Let me push play. I forgot to do that. I'll pause it. So if we take that to about right there, that's stereo A, that's the Earth. See what's happening here? So watch what happens. And this turns black and gray because that's the high density on the key here. And guys, like I said before, it's been a while since I've seen any of that kind of stuff come at us. It's been a good minute. Now notice as that gets to Earth, it gets really dense again because of this. So I do think if these models are to be trusted or if they're going to be correct without some sort of other event, I think this is going to come to fruition in about 4 or 5 days. That will be a significant thing we're going to need to talk about because that's going to be a lot of high dense material. Charged particles. Okay? Aurora, I'm not going to talk about that right now because nothing's happening there. Okay? You see the proton flux? Usually this line is right on top of each other. And because we've had a bump in that, we're not seeing that. It is showing a slight increase. Again, we are not in storm level, so please don't blow this out of proportion, okay? Storm level would be here. Look how far away it is. And even if it gets there, it's really not that big of a deal for us down here on the surface. So I'm going to show you guys a chart in one of my live streams about what each level of the radiation storms can, what it can do and what we can expect if we get those conditions. Okay? That'll be done soon. So I want you guys to know that. Haven't really had to talk about it because the proton flux has been staying down for like a year or longer. The absorption rate. This is what we look at when we see flares and that radiation. Notice where the energy was. That's radiation. It's on the poles because stuff comes in easier on the poles. So I'm going to pause that and grab the slide bar here. And when it goes black like that, I'm pretty sure that's just the tool kind of glitching out for a second. So I'm not really seeing much flaring from about 2 UTC to about 10. So, and that would match up with what it's showing up here. Okay, the last flare we had was right around midnight, so that would definitely be correct. Alright, the magnetosphere tools here, guys. This is where it gets kind of wonky for me. Push play. Well, first thing I need to do is update that. So, let me let this thing play. Now remember that, yeah, let me get these things going, okay? Sorry. I just, yeah, this is just really kind of odd. That's all. The red and the oranges are higher speed, okay? The sun's off to the left for people that don't know. So watch what happens here. Okay, we start to expand out. What's happening is we're starting to sense this stuff coming. Our electromagnetic field is actually starting to react before we could see it on this graph. Okay? It makes it seem as if we're pushing forward before anything hits us, and that's not really what's happening. Okay? So we keep moving, and see, shortly after we started moving forward, we get hit with that, right? And then it does all, I mean, it really just does this stuff. That's pretty chaotic. Now, we've seen it like this before. I'm not going to say we haven't, but this is definitely not what we typically see. This is really kind of strange, and this is why you got me talking about this. You hear me talking about this. This is really, really strange. Usually when we see stuff like this, the geomagnetism is elevated, sometimes even the storm level. So, let's see here. Let's look at the timestamp on that. That's at 9:20. One capture later, it looks like that. That's at 9:21. So there was no missing time. And then that's at 9:22. No missing time, and we go from that to that in 1 minute, and then that to that in the next minute. Yeah. And then look at that. Now, I'm not sure what to think about this one. You know, we do kind of, looks like we get some energy there in the front, but not much. And watch what happens. We're really pushing out really, really far. Okay, and then you can kind of see it push back. See that? And that's where we're at currently. So, as I'm making this video right now, it's about 5 Eastern time in the morning. This is what we got. So, let's look at it on the density. Okay, same kind of thing. The white is low density. The darker blues are the higher dense particles. See, not only are we pushing out, we're pushing in all directions. Watch. See that? Even before this energy gets here, we're starting to push out on the sides. And the energy is coming from the sun. Look at that. That's very, very low dense particles. That's almost solid white. Looks like an insane asylum. And then look what happens after that. Wham, we get a dense hit. Okay, we got that happened on this one too. See that? And then that. 1 minute apart. We're not missing time. That's usually what we see when we see missing time. That to that. But that's not what we're seeing. And then again, see? Notice how we kind of did this little open number here in the front again too. See how far we've tilted? Look at that. So I'm not quite sure what to think about this right now. Okay? I'm going to, do some more digging and see what's going on with this. But this is the pressure. This one here is actually kind of impressive also. Okay? Notice nothing from the front. And all of a sudden we start pushing and then all the pressure's gone. Now watch. Bam. Okay? Notice how impactful that was right on the front. See that? And then we see that. And then look how it disappears. What in the world makes our pressure disappear like that? that quick. Guys, we're talking... We go from that at 9:44 to that at 9:53. That's 9 minutes. 11 minutes. About 16 minutes. I mean, really? It's just really strange. And so, you know, we're not seeing a hit on the magnetosphere either on the graph, on the data up here. So, I don't know. I don't know what to say here. I wish I had a better answer for you guys. I'm going to try to figure it out, but as of right now, I can't really give you much of an answer. All I can say is our magnetosphere is definitely reacting, but the geomagnetism's not rising. So let's look at this. This is the sun's off to the right on this one. Okay, and I already showed you guys that last night right there. So let me keep moving. And notice how we get hit, right? And we just get inundated with pressure. Okay, then another hit. Remember, you know, pretend you can reach out and grab that and pull it to you like a curtain. And that's really what we kind of look like when we get hit in the front. It kind of will roll around, that energy wheel from the sun. This is a two-dimensional model, but we're talking about three-dimensional things. So we have to try to trick our mind into be able to get a good visual on that. Okay, and then we get that. I mean, that's very significant, guys. That's, I mean, any other time when we've seen this stuff, that magnetism is going crazy, usually. At least up to about a 4. I'm just not sure. Okay, so if we look at it over here, we're going to see something similar. Okay, now, you know, we did take some hits there. You can see how it's kind of bulging, but even that's not really showing a whole lot of magnetism mess up. The lines aren't really going blowed out like we seen yesterday. That's the solar wind map up there, okay? Obviously, you can see those hits right there. And nothing really, even according to that wind speed, it never got up over 600, I don't think. That's about what it looked like. So, yeah. Here's the current look at the sun. Let's go ahead and update that. So, you know, I don't see a whole lot going on here. Looks like we had like a little ejection up here, but again, that wasn't really nothing. It wouldn't be Earth facing anyway. That was that flare right around midnight. And then, you know, we had a little extension here, but nothing big. So, the 304 here. Dang it. Sorry about that. Yeah, just not much to show you there, guys. We can kind of see some filaments and stuff laying there, the dark patches, but yeah. So what I do want to show you real quick, though, is this. Okay, here's that coronal hole. So, yeah, we're going to be getting energy from that, for sure, in about 3 or 4 days. You know, it is long and thin. Typically, they don't really take that shape. But, you know, that shape doesn't bother me. It's not like something really, really crazy weird. It's just it really, most of the holes are a little bit more oblong. But that one there is pretty thin. So, but it is definitely open. So, you know, I bet we're connected to it, and I bet we're transferring energy now from the sun to the earth. It's on its way. So it's going to take it, like I said, 3 to 5 days to get here, depending on how fast it's moving. It does matter. So yeah. Now, Australian model. Let's take a look at this thing. Look at that. See it go way off the edge? Remember I told you I've seen it do that before? Why? Look at the proton density. 0. Now there is some density there. It's just like this one isn't geared low enough to pick it up. That's 0.0. If we went 0.00, it's probably more like 0.05 or something. It just doesn't show us that number, okay? There's still density there. Has to be, okay? Now, the speed, though, it's not very fast. So I'll take it back to the third. We'll watch it and see what it does here. And again, we're going to see it bouncing, obviously. It's just strange that we're getting this kind of activity. And, you know, if you watch the proton density and stuff, when it drops down is when our bow shock pushes out. Because we're not getting such an intense drive from the other side, from the sun side. So we're still pushing out all the time, and it kind of gets into a balance point between the pressure from the sun and our magnetic field. It gets a good pressure variance there, and it kind of just stays there. And when this thing is fluctuating around, means one of them is weaker than the other, or has lost some strength. Not weaker, just lost some strength. Now this here on the fourth, let's see what it does. It's going to go off the edge. I think we already seen it, but I want to show you guys it again. See, look at that. It's, yeah. I mean, you can barely see it here. That means we're way out past this. Guys, they make these graphs, and when they make these models, they're not going to make a model when they think that they're actually going to be seeing this a lot. You know, they would just go ahead and extend it out and put another number out here, right? But they didn't, because this is not normal. Now, we've seen it before, and we're all still here. You know what I mean? That's what I mean by that. But they don't think that this really should be happening that often, or they would have made the model a little bit different. They would add it out here. At least I would think. I think that's pretty logical to think like that. Anyway, geoelectric field. This is space weather's effect on our electrical grid. You know, you're seeing some little black spots and stuff flopping around there. Don't worry about those. It just means we're not really getting that much energy there. They're very, very geometrical because they're going from line to line, and sometimes they make those shapes. But you've seen how we kind of flash here too. Watch. See that and that? That's just showing you that we're still getting energy there. Okay? It's not sticking around or anything, and it's not causing us any issues. So now this is the LASCO C2. This is on SOHO, and it sits out in front of the Earth, always looking at the sun. So it's our view of the sun. That's a CME. Now looking at this, it looks like it's going off to the left of the Earth, right? Like straight to the left, not at an angle this way, because you look at it there, it almost even looks like it kind of angles back this way, right? But watch this. We'll go look at it from the side. Okay? So the Earth's here, and it looked like it was going this way, right? But it's not. Our perspective has changed here. We're looking at it from the side. So now we could combine both two-dimensional models and get kind of a better visual of what direction that's actually going. It's going out the back. But if you were just to look at LASCO C2 here, you would think it could even possibly come in this way, maybe even give us a glancing blow. But no, that's not the truth of it. The truth of it is, it's going out the back. It ain't going to touch us. No worries there. Okay, other than we might have another little ejection here, but even at that ain't nothing. That's Venus, if anybody's wondering. They call that the comet planet, in case you guys didn't know. Because a lot of times when it shows up on things like this, it looks almost like a comet because it's got a tail on it. CME tracker. There's that CME. I just showed you guys. Okay? It's not that powerful. It's not that big. But there it is. This one, the CME tracker, is even showing a high dense energy right here at stereo A. And then it comes around and hits the Earth. So now we got two models saying that. Earthquakes. You got one here in Alaska. It's not something that crazy, but then we get this one. That was at 7:37 in the morning on the 3rd. That was yesterday morning. Oh, it ain't been 24 hours yet. That's why this is a rolling 24-hour map. So it's going to show us right now. It's 5:30 Eastern time right now. So this is in 2 hours. That one, they'll take that one off this map, unless I change the setting. Okay. So if we're looking at this, and I want to show you guys this too for those that missed my live stream. This is Nevada, right? Mina. Okay. That's the one we had the earthquake, a few months back. And, it's been active ever since. But check this out. I want to show you guys this because I think a lot of times we overlook this. So I went to all magnitudes, right? And that ain't really what my point is on the all magnitude thing. But check this out. Obviously, we can tell that we got some swarming, right? But how much? If we were just to stay out here like this, we'd say, yeah, it's swarming kind of over here on the west coast. And if we didn't zoom in, we wouldn't know any better, right? So let's zoom in right to on top of Mina. Watch what happens. You guys see the amount of earthquakes you see now? That's a lot. Now again, I told you guys, Mike and Cindy did a video was it yesterday? Or I think it was yesterday. The day before that, Yellowstone had 86 earthquakes they reported on. So go check out Evolutionary Energy Arts. They're good people, Mike and Cindy, great people, and they do a good job over there. So I shouted them out a lot. But this right here, guys, is Yellowstone. And again, you get to see more the more you zoom in, obviously. But I just thought that was a pretty significant difference if you're looking at this. We look at it and say, oh yeah, it's kind of swarming. That looks about, what, 10 or 15 of them there? But you keep zooming in, and you see this. I don't even know how many's there. There's got to be, gosh, 60, 70 of them maybe, if not more. So, we got to do that. We got to zoom in. I even made the mistake yesterday during the stream. Okay? We had this one down here pop off. And again, let me back off here. Look. The big one showed up first right there. The 5-1 in Nicaragua, right? Then a few seconds later, that one looked like it was gone. And they plotted another one right on top of it for like a 4-2. But we didn't zoom in. I didn't zoom in. So I was like, man, they actually changed that while I was sitting there looking at it. They downgraded it. That ain't what happened, guys. I zoom in and look what happens. Here's the ones that they started plotting after the bigger one. That's why it's important to do this. I'm showing you my mistakes so you guys don't make the same one. So hopefully that helps you guys. It's kind of crazy. Earthquakes here in Canada. Nothing much to report here. Again, I was asked, how come do we get so many in the United States and we're not seeing anything elsewhere in the world? Well, because they don't publish other people's seismographs. That's why. That's why the USGS looks like the earthquakes stop at the border, right? They don't. Obviously, because that proves it right there. And I gotta say thanks to Menacing Muskrat because, they sent me that link. So I didn't know nothing about this. So I do appreciate that. Also, Ricky, I give a shout out to Ricky. Ron Tyler. Somebody else was trying to get a hold of me. I can't remember who was telling me. It might have been Axe or it could have been Arizona Raven. I'm not sure. I have to go back and look at my email. But can't remember who. for the life of me, I can't remember who was trying to get a hold of me. Sorry about that, guys. But yeah, we may be doing a live stream with somebody. I can't remember who it was. Daggone it. Anyway. So yeah. So let's go over to space weather. News.com. Not news, but spaceweather.com. And radio signals from the moon. The Chinese landed a craft there, and they now got, moon dust, moon rocks, for the first time since 1976. Okay? It says, Thursday, December 3rd, it was ready to leave. A small probe on top of the lander blasted off, carrying with it the first fresh lunar sample since 1976. Yeah. I believe this landed on the 1st, but I think it's left yesterday. So, yeah, that's significant news, and yes, there's going to be controversy around what I just said. We all know that. Anytime you talk about the moon, there's always going to be some strong opinions on both sides of it, okay? And I'm not going to get into that discussion right now. But, yeah. So, that happened, and now, near-Earth objects, not much to report there. We can take this back, and I do want to show you this because I think that this is kind of substantial. I explained this in my live stream yesterday. This is Noctolucent clouds. What that is what they tell us it is meteor dust that hangs around the poles, and certain times of the year it gets cold enough that the moisture actually surrounds the meteor dust in the atmosphere, causing ice around them, and that's what gives us the blue clouds. Now, what's significant about this is this season of these. There's a season for these, and it was supposed to start right around the 21st of November. It's way late. So there's a lot of people talking about this right now because it could mean that the temperature's higher up in the atmosphere, and it's not able to freeze around around that meteor dust. So, Scott talks about the jet streams and stuff getting all jacked up, especially around the poles and stuff. And it's just going to spread across the whole globe. It's going to get worse. The temperature and stuff's changing, guys. We know this. So we just got to keep an eye on it. So that's what I would say. You got to talk about glacier melt also. It's melting at a crazy rate. Scott was sharing some information with me about how it was all the ancient ice was supposedly it's been melted away, if I understood him right. And it's just new ice now for the icebergs. What's that mean though? What that means is that the salinity of the ocean is going to change. The salt level content. The salt content of the ocean water. And what that does is, it's just like an ice cream churner. You put salt on ice, you're able to do ice cream a lot better, right? So things are going to start changing in temperature and salinity, which means the underwater highways are going to change direction, slow down, and that will definitely affect the climate across the globe. If we just talk simply about the Gulf Stream, the Gulf Stream waters, the redwood forests, we've all heard the song, right? The Gulf Stream waters kind of go up like this. Let me back that up a little bit. Up like this, and they go up here, and they come around here, right? Why is that significant, and how can I show you how significant that is? Well, I just got to simply show you a couple things here. First thing I'll show you is England's roughly about right here, right? Moscow's about right here. They're basically on the same latitude line as far as how far north they are. Moscow gets brutal winters. We know that. United Kingdom does not. Why? Well, because the climate is changed because of the Gulf Stream water. It drags all that temperature and stuff around, guys. It changes it. So if that was to change and go different directions, different depths, temperature change there, all that kind of stuff, it can have a very severe effect on ocean life and global climate. So we got to pay attention to that kind of stuff. They did have a crazy little earthquake over here in Jersey I reported on yesterday. I was talking to Scott. Scott said that somebody said they could kind of feel it in Pennsylvania or something right over here. If I understood him right. So yeah. So guys, that is your update for this morning. I'll probably be doing a live here in the next couple 3 hours if anything pops off. If not, I'll come on tonight and do my regular live stream at night. And so we're going to end it there, guys. God bless. Yahusha saves, and you can drink this Kool-Aid.